We're all dreaming of this future where robots can help us out everywhere, in our homes, in factories, even helping with nursing care. And look, that's not just science fiction anymore. But there's one huge piece of the puzzle that's still missing, a massive blind spot that's holding everything back. So today, let's dive into the one thing AI desperately needs to learn to finally truly understand our physical world.
So, this is the big dream that researchers are chasing right now. It's called a foundation veridical world model. And you can basically think of it as a single universal AI brain that you could just download into any machine. A humanoid assistant, a robot arm in a factory, you name it. And boom, it would instantly get how our world works, ready to tackle pretty much any physical task you throw at it. All right, so how do we actually get there? Well, in this explainer, we're going to first look at why this is the next massive frontier for AI. Then we'll dig into that big blind spot I mentioned. After that, we'll explore the power of causality, which is the solution, bust a couple of common myths about it, and finally, we'll take a look at the road ahead for building this incredible causal future. We are really at this incredible moment in time. I mean, for decades, general-purpose robots were purely the stuff of movies. But now, a bunch of different advancements are all coming together to make them a real engineering challenge we can actually tackle. And what's so cool is how all these different pieces are just converging at the exact same time. You've got hardware, from full-on humanoid robots to electronic skin that can actually feel, and it's all getting cheaper and better. The computing power we're getting from new GPUs is just insane. The same foundation models that power things like ChatGPT are getting way better at seeing the world and making plans. And maybe most importantly, there's just this massive ocean of data to train on: simulations, robotics data, and literally countless hours of YouTube videos. It feels like all the ingredients for this embodied AI are finally on the table. But there's a catch. There's a really big problem, actually. The very same AI models that are driving all this progress, they have a fundamental blind spot when it comes to actually, interacting with the real physical world. Which brings us to the big question, right? If these models are so smart they can write poetry and create unbelievable images, why can't we just plug one into a robot and have it say, clean up the kitchen? What are we missing here? And here it is. Today's AI is built on one thing: correlation. It is unbelievably good at finding patterns in data, at learning that certain things just tend to happen together. But what it doesn't get is the why. It doesn't understand the cause and effect that actually governs everything in our world. This is such a perfect way to see the problem. An AI built on correlation watches a million videos and learns a pattern. Pick up mug, move to drawer, place mug. Simple. But a causal AI understands that the drawer has to be opened first. It can predict the consequences of its actions. It knows intuitively that trying to shove a ceramic mug through a solid piece of wood is gonna fail. And that's the huge difference between just mimicking a sequence of actions and actually understanding physical reality. Here's the classic example to wrap your head around this. A correlational model looks at the data and sees that when ice cream sales go up, so do the number of drownings. It just sees the pattern. But a causal model gets the hidden piece of the puzzle: hot weather. The sun makes people want to buy ice cream, and it makes them want to go swimming. Today's AIs, they're basically stuck just seeing the pattern, not the real reason behind it.
Okay, so this is exactly where causality comes into play. It is the missing ingredient. It's the key to giving AI the ability to reason about what will happen because of its actions, to finally understand the why. And that brings us right back to this foundation veridical world model. That word, veridical, is super important here. It basically means truthful, or something that lines up with reality. So this isn't a model that just sees patterns. It's a model that understands the actual underlying physical laws of the world. It's basically a causal brain, one that can accurately predict the real-world outcome of any action it's thinking about taking. But how in the world does an AI learn something like that? Well, it's not a single jump. Researchers think about it more like climbing a ladder of reasoning, where every single rung represents a much deeper level of causal understanding. And this is that ladder, the Pearl causal hierarchy. So, level 1, observation. That's where today's AI is totally stuck, just seeing correlations. Level 2 is intervention. This is actively doing something, like trying to open a drawer, just to see what happens. But the top level, the holy grail, is counterfactual reasoning. This is the ability to imagine what would have happened if I'd done this other thing instead. For an agent to be truly intelligent, it needs to master all three. Now, this whole idea of causal AI can get a little confusing, and frankly, there are a few pretty common myths floating around out there, so let's just take a second and bust the two biggest ones.
All right, first up, there's this idea that causal AI is some, niche academic field that's totally separate from reinforcement learning, the stuff that powers a ton of today's robots and game-playing AIs. But the reality is, they are basically two sides of the exact same coin. Think about it. Reinforcement learning is all about causality. An agent has to learn by taking an action, which is really an intervention, and then seeing the consequence, all to figure out how to get a reward. It's a causal discovery process baked right into its core.
So the second myth comes from twisting that famous saying, correlation does not imply causation. A lot of people hear that and just assume that it means any model that predicts things is, by definition, not a causal model.
But the real secret is in the data. Yeah, a model that's only trained on passive, observational data will only ever learn correlations. That's true. But a model that's trained on data from active interventions, from an agent that's actually out there trying stuff, can absolutely learn causal relationships. In fact, a true causal model isn't just predictive, it's basically the ultimate prediction engine, able to forecast the exact consequences of any action. Okay, so if that's the goal, what are the actual steps researchers are taking to build this causal future? What are the biggest hurdles they still need to get over?
Well, the road ahead really focuses on a few key things. First, they need to go beyond just vision and text and start integrating other senses, like touch and force. Next, they have to figure out the best way to blend massive data sets of videos we already have with smart, efficient, real-world experiments. They also need to use this new causal understanding to help robots plan their actions way more efficiently. And finally, they have to invent totally new ways to even test these models, not just on their accuracy, but on whether they can genuinely reason about those what-if scenarios.
And this quote from the source paper really just nails the payoff. A causal model isn't just a little more accurate. It's way more robust. It can handle new situations it's never seen before and still make the right call, because it's learned the actual rules of the game, not just some superficial patterns in the data. And at the end of the day, this is not just some academic thought experiment. Building causal AI is absolutely the key to creating robots that are safe enough to work in our factories, robust enough to be in our homes, and reliable enough to help with things like elder care. It's really the foundation of trust between us and these intelligent machines. But look, giving an AI a deep causal understanding of how our world works, that's an incredibly powerful tool. And as we build these machines that can truly understand why, we are faced with an even bigger challenge. How do we make sure that the goals they pursue actually line up with our own human values? Now that is the next frontier.